Hey guys, it's Professor Dave. Let's talk about thermochemistry.
He knows a lot about the science stuff. Professor Dave explains.
Thermochemistry is the branch of thermodynamics that deals with the heat absorbed or produced by a chemical reaction. A reaction can either be exothermic, one that releases energy, or endothermic, one that absorbs energy. This change in energy is represented by delta H, or the change in enthalpy for the reaction. For our purposes, we can think of the change in enthalpy as being the change in energy for the reaction, or the energy stored in all the bonds of the products minus the energy stored in all the bonds of the reactants. If there is more energy in the products, delta H will be positive, meaning the additional energy had to be provided, making it an endothermic reaction. If there is less energy in the products, then that additional energy was released, making it an exothermic reaction. Energy, which is the capacity to do work, can have many forms, like mechanical, electrical, chemical, heat, and so forth. And besides quantum mechanical exceptions, energy is conserved. That means it can change forms, like heat energy that evolves when the chemical energy in a broken bond is released. But it won't be created or destroyed. Heat, represented by the letter Q, is a trickier thing to define, but a good way to put it is that heat is the energy that flows between a system and its surroundings due to a difference in temperature. Heat will always flow spontaneously from an area of high temperature to an area of low temperature. For a system, Q will be positive if heat is being absorbed by the system, and it will be negative if heat is being released by the system. When temperature and pressure are constant, Q equals delta H, the change in enthalpy. When we discuss thermochemistry, we will discuss energies in terms of joules or kilojoules. Another common unit used by chemists is the calorie, which is equal to 4.184 joules. 1 calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. This is not to be confused with the food calorie, which is calorie with a capital C. This is actually equal to a kilocalorie, or 1,000 calories, also abbreviated as kcal. A thermochemical equation reports the change in enthalpy for a given reaction in stoichiometric terms. Here, the delta H listed is specific to the molar quantities given by the balanced equation. So if the number of moles of each substance as given were to react, the change in enthalpy would be as listed. To find the enthalpy change for a specific amount of material, just do some stoichiometry. If twice as many moles of material as are listed were to react, then the enthalpy change would also be twice as much as listed. Let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials, and as always, feel free to email me, ProfessorDaveExplains@gmail.com.